start recording. So just to inform again everybody that the webinar is recorded, and the recorded file will be uploaded on iPlanra webpage. Okay, well, yes, let's start with the second section of today's webinar, and we already say something this morning. Vera, if you want to introduce again today's webinar, and in particular, what is the topic of the second section today?
Okay, good afternoon. I'm Vera Ventura. I'm the chair of the Working Group 4 on Socioeconomic Impact of RNAi Solution. And it's really a pleasure for me to open the event, which is focusing on the contribution of RNAi for a more sustainable and resilient food system. This morning we had the meeting with stakeholders, and we talked about the challenges of European agriculture with producers. And it was a very interesting discussion highlighting the need for solutions and the high interest towards innovative strategies for pest and disease control like RNAi. This afternoon session is dedicated to policymakers and officers, and will be more focused on policies and strategies for the exploitation of innovation and innovative solutions for the agriculture. First, I would like to thank everybody for participation. And then we can have a quick look to the program. Maybe if Bruno, maybe you can share the program with your screen.
Yes, 1 second. Yes, now you see it.
Okay, so first we start with a welcome by Dominique van der Kerchove, this cost scientific officer who supported us and also helped us a lot in organizing these webinars. So thank you, Dominique. Then Bruno Mezzetti, the chair of the iPlanra cost section, will introduce RNAi technology and also present a paper, a recently published paper, which talks about RNAi and EU sustainability goals. Then we will have the intervention of Chike Lumba from Plant Production and Protection Division of FAO. And then Gisela Quaglia from DG Agri will give her speech on EU plant health research and innovation. The next speaker will be Domenico Deserio from DG Sante, speaking about the use of microorganisms as active substances in plant protection products. And then Paolo Lenzi from Efsa on the risk assessment of RNAi GM crops. And the last speaker will be Omar Amawi, presenting the PRIMA project for resilience and sustainability in the Mediterranean area. At the end, we will watch a short video that we recently produced to explain RNAi technology, basically. And then the roundtable with the participation of Nevena Alexandrova from FAO and all the speakers of the session. So if you, sorry, okay. The program is very rich. If you have questions for the speakers, please put it in the chat box, and it will be possible to ask questions to each speakers at the end of each presentation. But maybe it's better if we collect all the questions for the final discussion. Okay, so I think we can start with the first speech, the welcome from Dominique van der Kerchove. So thank you, Dominique, and the floor is yours.
Thank you. Can you see my screen?
Yes.
Can you see the slide? Okay. So thank you, Vera, and thank you, Bruno. Good afternoon, everybody. A warm welcome from my side as well to this webinar on policy organized by Cost Action iPlanra. My name is Dominique van der Kerkhoven, very well pronounced, Vera, very well done. I'm a science officer at the Cost Association. First of all, I would like to thank Bruno and Vera for inviting me to open this webinar. And for those of you who aren't familiar with the Cost Association, it will be my pleasure to introduce you to Cost. I will keep it very brief, a few minutes only, but it will help you understand the context in which iPlanra has been working. The assignment of Cost is to provide networking opportunities for researchers and innovators in order to strengthen Europe's capacity to address scientific, technological, and societal challenges. We fund bottom-up, excellence-driven, open, and inclusive networks in all areas of science and technology. Cost has 3 strategic priorities in its role in the European research area: promoting and spreading excellence, fostering interdisciplinary research for breakthrough science, and boosting careers of young researchers. Knowledge sharing has many advantages, and some important ones are arriving at a common understanding of problems, coordinating activities, pooling resources, reducing the risks, arriving at a synthesis and combination of pieces of knowledge, and also achieving synergies, making 1 + 1 more than 2. We have a large number of countries involved in the Cost actions. We have 38 Cost full members, 1 cooperating member, and 1 partner member. 32 of these are involved in Cost action iPlanra. And then there's the rest of the world. We have the near neighbor countries shown in blue on this map. And then we have the gray and orange countries, which we indicate as international partner countries. The international partner countries shown here in orange are currently involved in 1 or more Cost actions. Specifically for iPlanra, there's 2 near neighbor countries involved, Armenia and Jordan, and 2 international partner countries, Brazil and Uruguay. Now, for some more information on the Cost actions themselves, what exactly is a Cost action? In essence, it's an open space where ideas and people can grow without limits. It all starts with a great idea and with researchers from at least 7 different Cost countries forming a consortium and submitting a Cost action proposal. If the proposal is selected for funding, the action has 4 years to deliver on its objectives. And during these 4 years, it has access to a large number of tools provided by the Cost Association, like training schools, short-term scientific missions, dissemination meetings, etc. The output of the action will have a certain impact. This can be new ideas, new products, new knowledge, dissemination of the new knowledge, training, spin-offs, long-term collaboration, etc. This is also the course that has been followed by iPlanra, and it is now in the end stage of its lifetime. With these webinars, in which we are participating this afternoon, the action is aiming at having as large an impact as possible. And I'm confident that this afternoon's session will once again offer an opportunity for a most interesting and exciting knowledge exchange. Now I've come to the end of my presentation. I told you it was going to be only a few minutes. So for those of you interested in knowing more about costs, please visit our website, and you can discover there the many actions that we have already funded and that we are currently still funding. You can also sign up to our news or join us on our social networks. In the next presentation, Bruno will tell you more about the iPlanra action. Thank you very much for your attention.
Thank you, Dominique, and thank you again for your help and support.
You're welcome.
So the next presentation is about RNAi and EU sustainability goals. The speaker is Professor Bruno Mezzetti, chair of the iPlanra Cost Action. So Bruno, when you want.
Thank you. Thank you, Well, first of all, thank Dominic for introducing cost organization and also already introducing iPlanra. My presentation, it's again try to give some more information about iPlanra network and well, introduces the concept that the idea, how you say that the cost action starts from the idea. So also our cost action starts from the idea. So first, what is the problem? What is the general problem that we know that we everywhere we are discussing nowadays? So the fact that it is increasing the world population and we need more food, so the demand of food is increasing, and the arable land is decreasing more and more. And so we need to find more efficient solutions. So, and to increase production efficiency, have the same production, the same yield, the same quality, with the reduction of inputs for doing this, for having this type of production. And then one of the main issues this morning, we listened different presentation underlying the importance of defining new strategy for protecting crops. And if we learn that if we, for some reason, decide to take off some tools for protecting crops from diseases, then the losses can be very high, and the growers may have many problems, and also then after also the consumer can face an important problem with this issue. And clearly we need to guarantee the fact that we need to keep producing food, high quality and healthy food for our consumers. And that is one of the key points that also was discussed in the morning, how consumer likes to want to have safe and high quality product. So this is the main challenge. So we need to find the idea of the project. Okay, we need to find solution strategy to guarantee biodiversity, sufficient quality, food for all. So starting from this general challenge, the concept we're trying to think about is the need to integrate technology and find alternative strategy. And from this comes out the idea that we need to have the possibility to combine traditional strategy with traditional tool, with a new advanced tool. And we consider biotechnology as a potential new advanced tool, but as we see, there are many different types of biotechnology that can be taken in consideration. And so that among that, we focus on the RNA technology. And as I showed this morning, just a short two slides, the same two slides regarding the cost action 1520 223, that is on modifying plants to produce interfering RNA. And it started in 2016, and it has 34 European signatory countries, plus the other neighbor international countries that were mentioned by Veronique. Already from the title, when we had this idea, we were focusing more on the concept that plants could have been modified for producing RNA. But when during this last 4 years, comes out that practically by discussing in the different working groups that are involved in this action, we understand that the technology was having an evolution. So not only having implanted stable expression of RNA, but also topical application of RNA. So, and now at the end of, almost at the end of the action, we are at this point. We need to see what it will be the future of the technology. Which of the two solutions will have maybe an early impact in there. We are convinced that this technology will have an impact on agriculture. We need now to understand which of the two technologies, the two potential applications, will have an impact on future agricultural system. And we are still here to discuss this and see what are the main factors related also to the biosafety of these two applications, what can be the potential social economic impact, and again, how to improve knowledge and communication and see how far public acceptance can be increased. Again, this morning we discussed with many growers organizations that were really in some way open to this, to see the possibility to use this technology as an alternative or for solving so many problems they have. But this is something that it has to be expanded, and clearly we also need to reach the consumer and discuss and have more knowledge of what can be really the acceptance, the more wide acceptance of this technology. Well, again, the technology, in this case, I put this as a gene science technology in comparison with the gene editing technology. That are the two new gene editing is considered now the really new promising technology. In 2020, two ladies were nominated for the Nobel Prize in chemistry for developing this technology. This clearly is having a potential in terms of application for generating new plants, solving the problem of climate change and disease and pest control and so on. But we believe that we are convinced that also the gene silencing technology is having a position on this potential need to solve this problem. Because again, it's based on small molecules that can interfere with genes in the plant and on plants also, and other microorganisms. So the concept of the crosstalk. These small molecules can have a mobility inside the plant, and we can have the double application. So the implant stable expression or the topical application. Now it's clear that the topical application is reality and may have a potential development. It is for this reason that with a group of iPlanra, we have been discussing, and several papers were published, trying to understand the different mechanisms, different solutions, focusing on biosafety, focusing on some specific application and so on. But today I want to focus on these papers that has been recently published on trends in biotechnology. That actually it was for in a special section of Science and Society, in which we were trying to analyze the potential benefit that the RNA-based technology could bring to the EU sustainability goals. And so, in fact, this is what we are going to discuss also today, and this maybe it can be taken also in the next discussion. It is from this paper that also we developed the concepts that are expressed in the small multimedia video that we will show you later. We show this morning, but we would like to show again in the afternoon, because many people were now present, were not present in this morning. Well, in the paper we were describing the technology, how it works. So double-stranded RNA that can be designed with specific target, and then the mechanisms that is present in all eukaryote cell can work in with this kind of dicer proteins that splices that create this small single RNA sequence that can be transferred in can move inside the plant, and then after, when they identify RNA, messenger RNA that are complementary, they can target and stop, degrade, and so at this point have this effect of gene silence to stop the production of protein. So this mechanism is very specific. It works in all type of organism, and it has a benefit that it can be used for different type of application. And in this paper, we try to differentiate clearly the different steps that we need to follow if we want to have the two potential applications. So what is the final product can be a pest and disease resistant plant. So the fact that we can have a stable expression in plant, a stable expression of new double-stranded RNA, Or with the exogenous application of double-stranded RNA, we can have a new double-stranded RNA based product, so a new pest and disease protected plant. For achieving these two potential final results, clearly we have some common things. So we start to the idea that we have a problem, so a pest and disease that has to be managed, has to be controlled because we have a susceptible plant. So we can study the type of action, the genetic knowledge, improve the genetic knowledge on the specific pest and disease that we need to control. Then design double-stranded RNA that can target genes of that pest and disease. And this is a common thing that needs to be done in any case, independently from the two applications. At this level can be in designing, in identifying, designing this double-stranded RNA can be done already some kind of analysis that help you to understand if to demonstrate that this mechanism is very specific, and so you avoid to have some kind of off-target effect. So this is in terms of biosafety really important. Then, depending to the way that you decide to follow, if you go to the exogenous application, you need to find a way to produce double-stranded RNA and to formulate the double-stranded RNA. These two steps are really important. At the beginning, were considered kind of bottleneck, but now different companies are working on it, and there are now many new information showing that this production can be done at, let's say, already even a good efficiency and even at cheaper cost. And again, the possibility to identify new formulates by using different nanomaterials that can really increase the stability of double-stranded RNA and the efficiency of this. So the future of this new product will be practically specifically related to this fact: the reduction of cost of production and formulates that make efficient the molecular. And this is, I would say, really at the advanced stage of development. Clearly, then before to go to the market, as for all these products, we need to follow the biosafety consideration and then the rules. And this still is a little bit a question of mark, and we are here also to discuss this point today, how this new RNA-based product will be classified and which kind of rules will be applied. And then clearly is the development of a new based product. While if we want to have the implanted stable expression, we need to prepare a gene construct, including gene sequence that are able to express a double-stranded RNA. And then we can transform the plant. And that's the plant that in this case, we have to say absolutely is a GMO, because we are using the recombinant technology, recombinant technology. So we modify the DNA of the plant that is going to express not new protein, not a new enzyme, but just a new small fragment of nucleotide that has a function that we have seen now. On the biosafety consideration in this case, there are many studies already done, because in reality we know that there are already product plants modified with this type of technology approved in the United States and also in Europe. Efsa already perform some preliminary study, and later we will learn more about this. And there is the idea that all the information already available for the GMO safety can be in some way used also for the biosafety consideration that can be taken by the Efsa panel that will be addressed, will be nominated for assessing potential new dossier for the request of approval of new RNA-based product. Clearly here we know that the rules are the GMO rules, so we are not trying to force the modification of GMO rules. We know that are GMO rules, and we are aware that in this case there is a potential, there is a clear bottleneck, that is the acceptance of the consumer in terms of GMO. But okay, people say, well, forget it. I cannot say that that is a reality, but as a scientist, I'm not saying that I'm not convinced that the GMO are ended. If we demonstrate that there are benefits, we should really maybe reconsider the discussion on the potential use of the GMO. So that is in general what we need to do. Again, the very last two slides, we think that there is a very fast and continuous development in the progress in the basic research on RNA mechanism, mobility, stability, and so that it's what is needed now really to make this technology much more advanced and much more useful and directly applied. We need to know, and all technologies that is now available and is coming out from genome study are really important for this technology. And we need to clearly advance the study on the molecular mechanism, so how to really manage this kind of cross-kingdom RNA trafficking, so how the RNA can produced by a plant or spraying a plant can really interact with the host, with the pest and diseases. So studies on host pathogen and or pest interaction are really important. We need to understand how pathogen absorb or interact with double-stranded RNA. This is one of the main problems. There are sometimes concern or problem in having uptakes on having efficient uptake of double-stranded RNA. So also the delivery system, as we say this morning, is one of the main of the key point to be considered in development of this progress. We need to know that it happens that in any case pathogen and pest evolve also to this resistance. We need still we don't know how far that this potential application can be more stable. We need to understand how it works. We know that, as I say, for GMO, for X, we have the directive on GMO. We need to understand, and this is question mark, I hope that the next period, in the next month, I don't know, next year, this will be clarified. As a potential development, yes, we think that X are having, so the GMO approach implanted double-stranded RNA expression can have a really high potential, but probably the topical application can have a more fast development in the next period. After the discussion of this morning, I added also this last slide related to the, as far I know, so please correct me if this is wrong, but I got it from an official presentation. The slide it's more or less synthesizing how biological products are classified. New molecules are classified at EU level. And so if we consider the biological control products, in some way we see that they are more or less classic. We have the chemical pesticide, and then we have the biological biopesticide. So if we are in the chemical pesticide, clearly, well, it is, in my opinion, very clear, it's better than being classified as a GMO, but at least it's not a GMO, but this is clear for 6, but it's a chemical pesticide. If we can consider the possibility to have a new double-strand based product classified as a biopesticide, and this is something that we already discussed this morning, it has to be considered for the next future. Probably the potential of this new type of product can be very high for all different agriculture systems that we are developing and we are taking in Europe as an important tool. Yeah, to conclude, yes, as this is a network, I want to underline that with the standard cost activity in pre-COVID era, we were able really to reach a high number of researchers and to create a very large network. More than 200 persons were already involved in this network. In the COVID era, with the webinar, we increased a lot the number. So with all the bad situation we are facing with the COVID pandemic situation, we discovered the system of the webinar, and like it is today, like it happened in the previous webinar, I think that on the other hand, it can be considered a good tool for enlarging the dissemination activities that this type of networks need to do. I stop here and I thank all for listening, and I give back to Vera.
Thank you, Bruno. If you have questions, please write it in the chat. And I think we can move on with the next presenter, that is Chike Lumba. Are you there, Chike?
Yes, I am.
Good morning. And the title of his presentation is Crop Improvement at FAO. So thank you so much.
Oh, okay.
And the floor is yours.
Okay. Thank you very much, Bruno, Vera, and my colleague, Alexandrova, for making it possible for me to join you in this exciting event today. As Vera indicated, I will be talking about what we do at the Food and Agriculture Organization to get the most suitable crop varieties into the hands of farmers who need them. And before proceeding, let me just point out that the main focus of our work is not in countries like the members of the iPlanra. We work more in the food insecure countries of the world. However, the solutions that come from the developed parts of the world, such as Europe, solutions and products such as you are developing in this cost action are all relevant for the toolbox of solutions that we provide to our members. So I belong to the Seeds and Plant Genetic Resources team. I lead this team in the Plant Production and Protection Division at FAO. And I'm going to basically bring you some steps down from the very stimulating presentation that Bruno has made in order to basically situate the context in which some of your outputs could be used to address the everyday problems that confront us as a civilization. So I will talk about the Sustainable Development Goals, some of the drivers for food security and nutrition. Some of these Bruno has already touched upon. Then I will share some of the work that we do at the normative and operational realms. I also share some tools with you, and then I will provide some thoughts as to how we could all work together so that my engagement with you is not a one-off transaction, but rather that it builds the momentum for continuing to engage. So I'm not going to bore you with this. However, let us just bear in mind that the year 2030 is now barely, is less than 10 years away when we set as target these lofty goals of ending poverty, ending hunger, and such other things as achieving responsible consumption and production. So FAO is at the forefront of the efforts to end hunger and malnutrition permanently in the world. And as you may all be aware, the international community has set some targets for itself in the way of the indicators for monitoring progress towards the achievement of the Sustainable Development Goals. And FAO is a custodian agency for about 21 to 22 of these indicators. The team that I lead in particular is responsible for collecting data, for supporting members and collecting data and reporting on progress towards indicator 2.5.1, which relates to the ex situ conservation of plants and animal genetic resources. Now, as I said, we are less than 10 years away from this lofty target of achieving zero hunger. But indeed, how much progress have we made? This flagship publication of FAO that is known as SOFA, the State of Food and Agriculture in the world, in 2017 gave a figure of the requirement of a 50% increase in food production over a baseline of the figure of 2012 for us to be able to feed sufficiently everybody on planet Earth by the year 2050. Just last year, the SOFI, so there is SOFA, the State of Food and Agriculture, and there is, which is published exclusively by FAO, and then there is the SOFI, the State of Food Security and Nutrition in the World, published jointly by FAO, UNICEF, World Health Organization, IFAD, and the World Food Program. I invite you to read these. They are downloadable gratis from our websites. The statistics are rather dire. By the end of 2019, about 2 billion people on planet Earth suffered from some level of food insecurity and or malnutrition. And Bruno pointed out in very eloquent ways the obstacles that we have, the obstacles that we need to surmount in order to make sure that all these food insecure people, or that there is enough food for everyone on planet Earth. And climate change, the dwindling agricultural water and land, and all these were before COVID-19. So should we now publish the SOFI again, the statistics would even be more dire. So in the division that I belong to, the Plant Production and Protection Division, we are contributing to this goal of eradicating hunger and malnutrition by enabling the transition to sustainable crop production, intensification, and diversification. And Bruno has alluded to a number of ways that, you know, to measure how sustainable the progress towards the achievement of food security and nutrition might be, namely to produce enough food without damaging planet Earth anymore. FAO is coming up with a new strategic framework that is anchored on 4 aspirations: better production, better nutrition, better environment, and better life. If I have some time, perhaps during the panel, I could go into some bit of details on this. And our division, as the name implies, and there is a whole thrust on producing the crops, on protecting them, and there are a number of cross-cutting issues and a number of thematic issues. The team that I lead is responsible for the crops and varieties component. Meaning that our work ultimately contributes to harnessing the genetic gains of crops. But then that will be as a complement to sound agronomics and sound plant protection practices. So in the end, what we seek to achieve is to ensure that farmers have access to a genetically diverse portfolio of improved crop varieties that are suited to their production systems, to their agroecologies, and in particular are resilient to all the vagaries of weather and climate that are attributable to climate change. But even in this regard, one could then say, yeah, just make the varieties available to the farmers. But it's a lot more complicated than just wishing it and trying to transfer models that have worked in places to others, where other areas where food security and malnutrition still prevail. For instance, sub-Saharan Africa and South Asia and some parts of Central America. To give you an example, if you are familiar with the Centers of the Consultative Group on International Agricultural Research, their work, the products of their work are usually public goods. They are not encumbered by any intellectual property right regimes. Yet, only about a little less than 35% of all the improved crop varieties that the CGIAR centers generate in sub-Saharan Africa are adopted by the farmers. So we are aspiring to abolish hunger and malnutrition. 80% of the food that we consume are plant-based, yet the farmers in the areas where hunger and malnutrition prevail are not even adopting the crop varieties that are available literally gratis to them. And as if this wasn't enough challenge, more than 90% of all seeds used in the developing countries, especially sub-Saharan Africa, lack any level of quality assurance. So, bottom line, there is food insecurity and malnutrition, yet farmers are neither using the quality seeds and planting materials nor the suitable varieties. So that is the work that we try to do in order to reverse this trend such that crop production becomes optimal in these parts of the world. And we have this mantra that there can be no good crops without good seeds. And this is a fact that doesn't require further explanation. However, these seeds, these quality seeds are not just going to happen magically. They are indeed the end of a continuum of interventions that start with conserving the raw materials, if you may, the plant genetic resources for food and agriculture that are used in breeding those superior crop varieties using elegant tools such as RNA interference or GMO or genome editing or induced mutation, conventional plant breeding, to develop these varieties that are suited to the needs of the farmers. and then to have the responsive seed delivery system that caters to the particular demographics to ensure that these quality seeds get to the farmers, so they are able to benefit from the advances in science and technology that went into unlocking the potentials of these plant genetic resources for food and agriculture. So my team is responsible for the quality assurance of FAO's work in these three domains, usually with interventions somewhat seamlessly. So I've presented them in a modular form just for reasons of simplicity. We use the second global plan of action on plant genetic resources for food and agriculture. It's an internationally agreed framework with 18 priority activities covering in situ conservation, ex situ, sustainable use is FAO's speak for plant breeding, for pre-breeding, and then build and seed systems, and then building sustainable institutions. So there are these 18 priority activities that countries commit to in order to conserve plant genetic resources and to use them sustainably in order to address development goals relating to leveraging sustainable crop production to address the scourge of malnutrition and food insecurity. To give you an example of the kinds of things that we do, last year we supported 44 member nations with developing strategies, capacities, and tools for working across these three modules. And as an example, the kind of outputs that we produce would be like a draft of a planting material certification system in Georgia, a seed law in Nicaragua, setting up seed producer groups in Mozambique, and supporting Sri Lanka with the implementation of the National Biosafety Framework according to the Cartagena Protocol on biosafety, which is the safe way to make use of genetically modified organisms. Another thing that we did a lot last year also was the support to about 48 member nations with emergency intervention, helping them to restart crop production after emergencies that could be man-made or natural disasters. And in this regard, FAO had to procure seeds worth about 30 million US dollars. As an example, in South Sudan alone, 11,000 metric tons of seeds of 20 crop varieties were bought. And in Afghanistan, for instance, just wheat alone, 4,000 metric tons. We by normative, I mean that FAO lends itself as a neutral forum for members to come together and agree on common standards for doing things. In our own case, that would be the conservation and sustainable use of plant genetic resources for food and agriculture. What we are now working on is the publication of the third report on the state of the world's plant genetic resources for food and agriculture that will cut across these three domains that I mentioned, in addition to the institutional and human capacities. The first report was published in 1997, the second report in 2010. We are hoping to publish the third report by 2023. Something that we do quite a lot is the development of tools. I alluded to the second report on the state of the world's plant genetic resources that we published in 2010. We also published the gene bank standards so that there is a common standard operating procedure for conserving plant genetic resources ex situ. to help countries with implementation of the second global plan of action, we also develop guidelines for developing national strategies. We also published a voluntary guide for national seed policy formulation. All these are aimed at supporting countries overcome these barriers that I had alluded to. This is technical guidelines for national level conservation of crop-wide relatives, which we know are rich repositories of novel alleles that can be used for improving the crops that they are related to. There is also the voluntary guidelines for the conservation of land races and farmers' varieties for those that are interested in heirloom varieties. This will be useful. Something that we have done quite recently is a 6-module seed toolkit that is published in English, French, and Spanish, and cutting across these different modules of the seed value chain that can be used for supporting capacity development, institutional and human, so farmers can have access to the quality seeds and planting materials that they need. And I had alluded to this. I don't know if you are aware, but most of your countries are FAO members, virtually all. We deal with these policy regimes under the auspices of FAO's Commission on Genetic Resources for Food and Agriculture, and our team, the Seeds and Plant Genetic Resources, we provide the Secretariat for the Intergovernmental Technical Working Group on Plant Genetic Resources for Food and Agriculture. We'll be having a session, the 10th session, in June. Unfortunately, it will be a virtual meeting. So these are means for engaging and interacting with us. I also mentioned these several country-level interventions. We can also collaborate through those. We're always looking for the best minds to proffer solutions for the work that we do. FAO has a substantial convening power in bringing people together, stakeholders of diverse leanings and belief systems and backgrounds, in order to debate and hopefully come to a consensus on certain themes, even if they are difficult to grapple with. And we will be having a global conference on green development of the seed industry sometime towards the end of this year. We will be publishing that and inviting participation from colleagues. And I thank you very much for listening. These are the members of the team that I lead, and I believe at least one person found the time to join. I thank you all very much for listening. Thank you. Over.
Thank you so much, Chikelu. Very interesting presentation and the very important message you gave. Then the last speaker, Omar Amawi, is asking to anticipate his presentation. I ask to the rest of the presenter if it is okay for you, for all of you. And I also ask to the presenter to say possibly within the time limits, because the program is very rich. And so if it's okay for everybody, I could anticipate the presentation by Omar Amawi. Okay, thank you. Thank you. They're saying that it's okay. So Omar, good morning.
Good afternoon. Thank you
Good
very much.
afternoon, sorry.
That's all right.
Omar Amawi is Deputy Director from the Prima Foundation, and he will give his speech on the Prima project, a partnership towards resilience, impact, and sustainability in the Mediterranean. So thank you, Omar, and the floor is yours.
Thank you very much. Hope you can see my screen, and thanks to all other presenters for giving me this advantage. Actually, maybe as much or as many of you have a very tight schedule, so I really have to leave because we have so many things in the pipeline. And tomorrow, hopefully, by the end of the day, we will be launching a new call for proposals. So this is one of the major announcements that I am making today, although that we had an info day about 2 weeks ago about the content and about the upcoming annual work program and the new call for proposals that is launched annually by Prima. But tomorrow, or like during the weekend, will be the official launch for this proposal, for this call for proposals. So we encourage all those who are interested to really benefit from this and to consider the application and to spread the word about this call for proposals. More information is coming up in my presentation, which I'll be talking about Prima, which is the Partnership for Research and Innovation in the Mediterranean area. This program, let me see how to, okay. All right. Okay, well, I don't know how many of you have heard about Prima, but Prima is a program that has been ongoing for almost 3 years right now. I will give in brief some background about this program, what it does, what has been achieved so far, and the mechanisms and the strategies and the tools that we are hiring in order to implement this program. To start with a little background about this program, so it came as an idea to respond to the emergent or to the needs of the region, and here we are focusing mainly on the Mediterranean region, both north and south. When we're talking north and south, we're talking about both shores of the Mediterranean, so including the European countries and non-European countries, in this partnership that is aiming at some good objectives in order to work together and to address the challenges that we are together facing in the Mediterranean. As you see here, we are talking about climate change, population growth, availability and security of water and food, a topic that has been mentioned several times today. So I think we are talking about the same challenges, the same issues, and Prima is a program that is really focusing on these issues with more issues to consider. The pronounced objectives, and what are the objectives? Of course, the major ones, we are talking about the alignment of national R&I programs, research and innovation programs. Since we are talking about partnerships, then we need to make some alignment so that we can all direct our resources to the same direction in order to tackle the same problems with a more effective way and a more efficient way. Critical mass of actors and resources, trying to create this in the Mediterranean area again, and strengthening the R&I capacities. All of this together will create those research teams and will hire all these resources in order to be efficient and effective in addressing our challenges. I'm going very quick because I know that I have only 15 minutes. So if you are interested to know more about these, of course, you may visit our socials and website, which I will be providing at the end, or you may contact me directly through the email. Prima was built on a unique principle, actually, of equal footing, where all countries supported by the European Commission are guiding this It's a 10-year program that started officially in 2017, and then we'll have 7 years of annual work programs or calls for proposals, followed by 3 years for implementation. Currently, we are, of course, discussing the continuation of this program beyond the preset 10 years period for this program, but we are hoping that this program will continue and have a longer period for implementation, building on the achievements that have been done so far and the lessons learned from this period. Again, in summary, what are the vision and the mission of the program? We are aiming at a sustainable use of natural resources, economic growth, and sustainable and stability. Again, this has been mentioned several times today, and PRIMA is taking this into consideration seriously and working towards it, and trying to achieve this sustainable impact and response to the needs of the region through applying some innovative and applied scientific research projects that could really make the difference in the people's life and in the aspects that are related directly and indirectly to the everyday lives of the people of this region. The mission, as stated here, is to achieve, support, and promote integration, alignment, and joint implementation of research and innovation initiatives under a common research and innovation strategy to tackle the diverse challenges in water scarcity, agriculture, and food security. And again, these topics are the topics that we are specializing in and focusing on in this program. The thematic areas are becoming very clear now. We are talking about water management in general. We are talking about farming systems and agro-food value chain. So those are the main 3 themes that PRIMA is focusing on, with some set of priorities that have been identified in our strategic research and innovation agenda that has been prior to the launch of this program, which is an outcome of an intensive exercise of consultations, discussions, meetings, readings, and referring to almost everything relevant to these topics in the region, so that we have set those priorities. For example, it was mentioned today, advanced technology in agriculture and irrigation and food production. So this is one of the priorities that has been identified. Market-driven innovation, and this is again something that we consider seriously in our topics to be selected for fundings. So if you are again interested in knowing more in detail about these priorities, they are all available on our website in the strategic research and innovation agenda. And every year we make this exercise of identifying the most relevant topics in order to continue on our funding strategy to achieve by the end of the 7 calls the goal that had been set at the beginning, and to hopefully achieve the foreseen impact in the region. The impact, I've talked about this several times, but as you may already guess, that we are aiming at the social impact, the economic impact, and of course the environmental impact, and those are in general the items or the main pillars of sustainability. We have 2, let's say, methods or modes for funding through the program, namely Section 1 and Section 2, which is every year we include those 2 sections in our annual work program. And the major differences between Section 1 and Section 2 is that Section 1 is fully funded by the European Commission contribution, the financial contribution into the program. I forgot to mention that the overall budget of the program over the 7-year implementation period is around €500 million, of which 220 million euros is coming from the European Commission as a contribution for the program. And the rest of this money, which is around 275 or 280 million euros, is coming from the 19 participating states in this program. Of course, the criteria followed in Section 1 is following strictly the Horizon 2020 guidelines, and in the Section 2, we are following the participating states funding rules. And this was, again, one of the goals is to make the alignment between the even the funding criteria between the countries, and several countries through this partnership have worked on adjusting their funding rules in order to fit better into the PRIMA program. The evaluation process, very briefly here also, we make the calls open, as I mentioned, tomorrow or in the next couple of days. We'll be launching the call. It will be open for a certain period of time. Then we receive the applications, which is we are following a two-stage or two-step application process, where they submit the pre-proposal first, it gets evaluated, and then it goes back for those selected projects to inform them to apply to submit the full proposal. Actually, again, we give them some time. They submit the full proposal, and then it is evaluated, and then finally the decision is made by the PRIMA Board of Trustees. And of course, in Section 1, following the EU Commission rules in Horizon 2020, and for Section 2, we are following the funding agencies' national regulations. In brief, I will talk about what has been done so far. I said that we are in the middle of the, let's say, the life of the first cycle of PRIMA. So we have launched 3 calls so far in 18, 19, and 20. What's unique about this program actually is a very competitive program where we receive a very large number of applications every year. In this slide, I'm showing the numbers related to Section 1, which is fully funded by the financial allocations coming from the European Commission. And you see, for example, in 2018, we have received 457 applications, of which 32 were selected for the second stage. As I mentioned, we are following the 2-stage application, and unfortunately, we were able only to fund 9 projects in this cycle. So in this regard, although it's a very competitive process, but we still encourage all researchers to consider seriously applying for PRIMA. We are not, I would say it, and this is maybe, I will not say personal, but more strategic approach for funding. We are not mainly funding agency, because if you are funding agencies, that means you have larger amounts of money that could fund more projects, and then the funding or the success rate will be much larger than in PRIMA. But in PRIMA, we have limited financial resources, so we are making the process, trying to make it as efficient as possible according to the highest standards followed in such a process, in order to select those projects that are really worth funding, and they have the capacity and the potential to fit in the goals of creating the socio-economic environmental impact that we are targeting in PRIMA. In 2018, the total budget was around 18 million. In 2019, it was increased to about 27, 28 million, and continuously increasing in 2020. It was 33 million. The upcoming call will be also around these, not a little bit more, but again, we are expecting a high number of applications. So please consider this call and try to help us spread the word and ask more serious and more applications, good applications to be submitted to PRIMA. Here, the situation is a little different, which is not much different, but in Section 2, which is financed by the financial contribution of the participating states. And this is something that is happening actually not very often in the region, where the funding agencies or the participating states seriously put some money towards the program. And you can see here, we are talking about 27 to 30 million euros that are allocated every year, or being able to use this money every year to fund some projects. It's very competitive. Again, in the last call, like 2020, we had 153 submissions, of which 31 projects were funded, and we are continuously trying to improve this success rate. So you may see that our success rate has been increased significantly between 2018 and 2020, and hopefully it will be progressing more and more in the future. I guess this is all what I wanted to say. I thank again all the other presenters for giving me the chance and the advantage to present first. And thank you very much for inviting us to take part in this workshop. Back to you.
Thank you, Omar Amawi. Actually, during this morning session, one of the presentations was focusing on a running PRIMA project, which developed innovative solution for with RNAi technology for the strawberry production, and it is a very interesting project. So, thank you.
Thank you.
And let's move on to the program. The next speaker is Gisella Quaglia. I hope the pronunciation is good. Is it Quaglia? A research program officer at DG Agri. And the title of her presentation is EU Plant Health Research and Innovation. So thank you, Gisella.
Thank you. Can you hear me well?
Yes.
Okay. So good afternoon from my side, and thank you very much for the invitation to present today in this webinar. I work in the Research and Innovation Unit in DG Agriculture and Rural Development, and I have prepared a presentation that's focused on the EU plant health research and innovations. I will cover some policy context at the beginning, talking about briefly about the Green Deal and the Farm to Fork strategy, but moving quickly to the agriculture research strategy that we are applying, that makes two policies working together to accelerate the transition to sustainable healthy food system. I include in my presentation two nice examples from Horizon 2020 that I would like for you to have a look. And finally, I will introduce the new research framework program that we are launching this year, the Horizon Europe. So starting with the strategy, if the presentations, oops, here, okay. So probably many of you have already seen this slide, but the Farm to Fork strategy is at the very heart of the European Green Deal and aiming to make the food system fair, healthy, and environmental friendly. But the Farm to Fork strategy intends to accelerate these transitions with the overall goals to strengthen the resilience, to ensure food security in the face of climate change and biodiversity loss, to reduce the environmental and climate footprint of the food system, and lead a global transition towards competitive sustainability from farm to fork and tapping into new opportunities. So we have already heard a little bit about the target also this morning, so I will not put much attention to them, but this strategy comes with quantitative targets regarding pesticides and nutrients, and also antimicrobials. The aim is to reduce the pollution, to reduce the dependency on pesticides, and to increase the area of organic farming. Regarding the topic of the webinar, we can focus on the pesticide targets that they aim to reduce by 50% the overall use and risk, and also to reduce by 50% the more hazardous pesticides. But these targets are important to consider because they set the direction and also motivates the actors to pursue into action. So to achieve the ambitious targets, of the farm to fork strategy, we need research and innovation as enabler. That's the key. Research and innovation can help us to develop and to test solutions, to overcome barriers, and to uncover new market opportunities. That is clear. So research can provide tools and means for many of the challenge on the way to achieve these ambitious targets. So the good news is that in DG Agri, we are not starting from scratch today with research and innovation. Since 2014, DG Agri has taken a leading role in programming and implementing agriculture research and innovation. And we have developed a long-term strategic approach that you can see on the screen. There is the cover of the final paper that includes all the strategy that we set that in 2016. At the very core, that's the figure that you can see on the right, there shows the 5 priority areas. And the core, one of the priority areas is healthier plants. It's also together with animal, healthier livestock, resource management, and the integrated ecological approaches from farm to landscape level. But to put this strategy in action, we can make use of 2 European policies. One, the Common Agriculture Policy, the CAP, and the second one is the Research and Innovation Framework that in the past was Horizon 2020, and it will be from this year Horizon Europe. These 2 policies have been working in close synergy since long time. EIP Agri, it aims for the European Innovation Partnership for Agriculture, Productivity and Sustainability, and it was established under the Common Agriculture Policy. EIP Agri is an initiative that promotes innovation to make the agriculture and forestry sector to fit for today's global challenges. So you can see on the chart the different connections from the EIP Agri activities and also from the research and innovation side from Horizon 2020. In Horizon 2020 projects, we have successfully implemented what we call the multi-actor approach that requires the participation of a variety of actors, farmers, food businesses, consumers, advisors, researchers, that complement the knowledge and the skill and can develop innovative solutions. So this approach allows to better taking into account the needs of the farmers, the advisors, but as well help us to speed up the uptake of these solutions on the ground. So the green arrows indicates that there are a lot of links and collaboration between Horizon 2020 and EIP Agri activities. What is important to highlight in this graph is that Horizon 2020 projects or research projects and EIP Agri projects aims to bring research and practice together closer and to maximize research and innovation. But moving forward to plant health topics. Under Horizon 2020, we had funded more than 30 projects during the past 7 years, with an investment of over 160 million euros. In this figure, we can see some of the topics and the relevance of some of the topics that were covered during these 7 years with many of these projects, from pests, from plant health, plant protection, integrated pest management, plant protection product, but also considering crop diversification, intercropping, agroecology, and yield stability. To know more about our projects, I invite you to have a look on the Agri-Research fact sheet that I will post the link then later in the chat. But for today's presentation, I want to show two examples of 2 projects, running projects that are related to the iPlanra webinar that gives you a flavor of the variety of the topics on the project that we had funded during these years. one of the projects, both projects that I will show deals with 6 for innovations in plant protections. Both projects attend the same call, but present different solutions and alternatives. So the first one is Super Pest, that's aimed for innovative tools for rational control of most difficult to manage pests that they call super pest. And the disease that they transmit, you can see on the screen also the link to the project. The project will help to evaluate a suite of innovative products, tools, and concepts, and also to integrate these with existing approaches in data-driven integrated pest management programs. It's coordinated by the Agricultural University of Athens, and so far this project has shown very interesting results regarding biological control agents, also tools for screening anti-resistant potential of novel compounds. They have tested environmental friendly biopesticides and has working and show results on evidence-based IPM. If you are interested on more details and more results, you can visit the website that is very comprehensive. The second project is ViroPlan, that also aims for, that also will provide solutions and innovations in plant protection. And ViroPlan is a Virom NGS analysis of pests and pathogens for plant protections. And ViroPlans apply for next generation sequencing technologies and also empirical biological experiments to develop new environmental friendly virus-based control strategies against bacteria, fungal, and insect vector diseases. What is interesting in this project, it's that it's a multi-actor approach project. So the consortium is coordinated by the National Research Council of Italy, but 17 partners from different European countries are part of the consortium. But also it's not only research organization, but also SMEs, farmer unions, and no-profit or a foundation. The project will include also a study on the social acceptance of virus-based natural products that is very interesting to find out the results of this. So now coming to the end of my presentation, I would like to talk about the future, but also the present. That is the new research and innovation investment program, Horizon Europe, that is launching this year. Horizon Europe has 3 pillars. Excellent science and innovative Europe is the pillar 1 and 2, but I will focus today on pillar 2. That was designed to fund research and innovation and tackling societal challenges and also to reinforce technological and industrial capacities. In Pillar 2, it contains 6 clusters from health to climate, but I will like to point out Cluster 6, that is food, bioeconomy, natural resources, agriculture, and environment. This cluster, where agriculture, forestry, and rural areas is part of one of the intervention areas, has a total budget of 9 billion euros for the next 7 years. And this will include all the research and innovation calls related to agriculture, forestry, and rural areas. So I invite the audience and the researchers in this webinar to stay tuned, because the first work program of Horizon Europe with the calls for this year and for next year is going to be published very soon, and has a variety of challenges to address and to provide solutions. So to finalize, I would like to show what's in plant-related research in Horizon Europe. So I can mention at this time what are the research and innovation priorities that we have in our unit. And First of all is to enhance capacities to prevent, monitor, and control plant pests. But also we need to develop safe and environmentally friendly methods for plant protection and from weed control. This includes a priority of increase the resilience of plants to biotic stresses and to bring more diversity into farming and forestry systems. And finally, is to improve the conservation, the management, and the use of plant genetic resources, enhancing also agrobiodiversity. So as I said at the beginning, and to conclude, research and innovation can be an enabler for the many challenges on the way to achieve the objectives set in the Farm to Fork strategy. And we are looking forward to provide these solutions to our farm systems and to make food systems fair, healthy, and environmental friendly. Thank you.
Thank you, Gisela, for very important information you gave us. Again, if you have questions, please write it in the chat box, and then we will use them when we open the discussion in the final roundtable. So the next speaker is Domenico Deserio from DG Sante, speaking about the use of microorganisms as active substances in plant protection products. So, Domenico?
Yes, can you hear me?
Yes.
Good afternoon to everyone. Can you see the slide as well?
As well.
Good, thank you. So good afternoon to everyone. Thank you, Vera, for introducing me. I'm Domenico Deserio. I'm policy officer at DG Sante in the unit dealing with pesticide and biocide. Here today to talk about the use of microorganisms as active substances in plant protection products. So something not directly related to high RNA, but still useful for the biological transition toward more sustainable alternatives. Just to make sure we starting from the same page, let's say, just a little brief introduction to the EU regulatory framework concerning the pesticide in Europe. The plant protection products or pesticide contain, as we know, an active substance. It's important to make a distinction between active substances and plant protection product as regard the approval and authorization process. Important to say that active substances for plant protection products are approved at European level, while plant protection products are authorized at member state level. And this is the first important distinction. As concerned the active substance approval, so at European level, I would like just to briefly introduce you the whole process. First of all, of course, an applicant who wishes to submit the application for its active substance has to submit a dossier. This dossier concerns some data about the active substance, and these data to be submitted are defined by two regulations, which are actually called the data requirements. And the dossier gets submitted to the rapporteur member state. The rapporteur member state, one of the 27 member states, perform a risk assessment. And this assessment is regulated by another piece of legislation, which is the Uniform Principles of Evaluation of the Plant Protection Product. After this first risk assessment is carried out by the rapporteur member state, then the dossier is taken over to Efsa, the European Food Safety Authority, where the actual peer review of the risk assessment is performed. Once the peer review is concluded, Efsa published the Efsa conclusion concerning the active substance, and this is at the Commission what we get, the Efsa conclusion concerning the active substance. We do our evaluation, and at the PAF level, so at the standing committee level, the standing committee for animal food and feed, plant animal food and feed, the final decision is taken on whether or not to approve or non approve the active substances. So basically we have two phases. One is the risk assessment at the rapporteur member state and EFSA level, and the second step is the risk management. What we what we usually face when we deal with dossier or conclusions concerning active substances, especially for microorganism, is the poor quality of the data provided or lack of data, which ends up in data gap. This hampers the whole process of the evaluation, of the risk assessment, of the risk management activities. So in order to improve the whole system, we have decided to enforce what is, let's say, the bottleneck of the system. So the provision of the data requirements, and the way these data are evaluated. So that's where we are putting our effort in improving, let's say, the situation for biological active substances. But why microorganisms among all the biological active substances available? To say that, just a brief introduction of the Green Deal and Farm to Fork. I know you've been talking about this the whole day. So you know that the Farm to Fork is a program included in the whole big strategies of the European Green Deal. We know that there are several objectives of this Farm to Fork, but what I would like you to focus on now is the first here, the reduction of the 50% by 50% of the use of chemical pesticide, and the achievement of at least 25% of EU agricultural land used for organic farming activities. In order to foster these two main objectives of the Farm to Fork strategy, we are focusing on what can really take over from chemicals. Among several tools, of course, biopesticide are fundamentals. In the left side, in the left-hand side slide, you can see that among the whole application submitted to the rapporteur member state and then the commission at the end concerning active substances, the number of biological pesticides is increasing in the last years. In the right-hand side of the slide, you can see that among the biopesticides which are approved at EU level, the biggest part is represented by the microorganism, which is this bottom bar, which is also increasing, as you see, is growing and is still the biggest part of the whole set of biological pesticides. And this is basically why, in order to foster this target of the Farm to Fork strategy, so the reduction of the dependency from chemical pesticide, we are focusing our activities on the microorganism used as active substances in plant protection products. In order to do so, our main effort is focused on the revision, as we said just 2 slides before, of the data requirements and the uniform principle regulating the data provision and evaluation of this data of the active substances. So namely the regulations 283/2013, 284/2013, which are the data requirements, and the regulation 546/2011, which is basically the regulation of the uniform principles. We are also amending the annex of our main regulation, the regulation 1107/2009 as a complement, but I don't want to get into too many details. We are clearly, as you can see from here, only revising the Part B, because these regulations are made by Part A, which is for chemicals, and the Part B, which is for microorganisms. On the top of it, in order to, let's say, facilitating this, the implementation of such amendments, we have also in 2020 also published 2 guidance documents, one on the risk assessment linked to the metabolite of concern produced by microorganisms, and the other one on antimicrobial resistance, approval and low risk criteria linked to antimicrobial resistance. Last but not least, also some training activities for risk assessors at EU level. To get into some of the concept of the amendment of the regulation, so the data requirements and the uniform principle, what has triggered the need for updating this regulation is the fact that the current regulation into force is basically mirroring, let's say, the chemical approach. What is lacking at the moment is an approach which is really tailored for the biological properties of the microorganisms. So we need to revise the mindset with which we assess the data for active substances which are living organisms and not chemical. So, and also we need to exploit, let's say, the knowledge we have developed by assessing the substances in the last years, and the new science, new knowledge, new technologies developed in the latest years. Our intention is to require what is really needed. We don't want anymore to, let's say, require data which are nice to know. We want really to focus on the need to know approach. So what is really needed, and being again the microorganism, living organisms, we are also building up a regulatory framework which is tier-based, so which is including many requirements which are conditional. So based on some biological properties of a microorganism, some requirements might be required or not. For instance, if the microorganism is a fungus or if it's a virus, certain requirements would be or not required. This is more stressed in the new amendment of the regulation. Also, we are giving a lot of weight on the weight of evidence approach. So an approach which is based on reducing the studies to be performed and giving more importance, for instance, to the already existing knowledge. I don't want to get into too many technical details, but just to give you some flavor on the technical contents of the new regulations, we are, as is happening like in many other scientific areas, we are trying to reduce as much as possible studies on animals for several reasons. We have ethical reasons, first of all. We have other reasons, such as the reduction of the burden for companies when it's not really needed to perform such studies. And last but not least, we need to take into consideration that if we want to assess, for instance, what is the pathogenicity, the possible pathogenicity of a microorganism for humans, animal models are not always suitable because the host range of a microorganism can be narrow, and what is pathogenic for rodents can be not pathogenic for humans, and vice versa. In order to reduce also as much as possible studies on animal, we are giving more importance to the pre-submission meetings, where the applicant basically meets the competent authorities of for instance, Efsa or the member states, in order to really decide which are the studies which are really needed to carry out a proper dossier. As said before, a weight of evidence approach will be given more importance. For instance, a metabolite of concern is something which is recurrent, because currently we have had several issues in the dossier we received concerning metabolite of concern, because microorganisms can produce several metabolite of concerns, but according to certain environmental circumstances. So the evaluation on what is needed to be assessed is really complicated, and it needs to be better defined. And the weight of evidence approach could be the key. I don't want to, again, get into many other details, but just to say that in comparing to the regulations currently into force, we are setting a better separation between the requirements which concern the pathogenicity of the microorganisms from the requirement which concern the toxicity of the chemical compounds which can be present in the plant protection product. This is something which needs to be clarified, because in the current regulation is not clearly set, and there was space for improvement, and we took action on that. This is just like to give you, this slide is just to give you a brief overview on the time frame. We have started these activities in Q4 2018, and DG Santé is carrying out this activity by chairing the biopesticide working group, which is a working group composed by experts appointed by several member states, and some like other components and other members like Efsa, OECD, ECA, and from time to time, according to the situations, we invited also industries representatives. We have now, in a moment where we have the drafts of the regulation quite stable, the biopesticide working group has reached, let's say, agreement on most of the drafts, and we are now assessing this draft at the standing committee level. So the PAF, the Standing Committee for Plant, Animal, Food and Feed, where the member states are evaluating the draft, and possibly this will be finally voted by the end of the year, to be then scrutinized by the European Parliament and the Council in Q1 2022, where they will probably be adopted. As said before, the revision of the data requirements and the uniform principle is not the only activity we are taking on this. To support their implementation, we have also developed last year 2 guidance documents. As also said, one of the guidance is on metabolite of concern produced by microorganisms, because this is one of the main issues we currently face when we assess microbiological active substances. We put a lot of effort in really make it clear for both the applicants and the risk assessors as well, which are the metabolites of concerns, which deserve attention. And so the guidance is basically divided into 4 stages. There is really like a decision tree toward which the applicant and the risk assessor might check whether, based on data obtained by studies like testing, laboratory testing, or existing information available in the literature, might check which metabolite can be of concern, because the microorganism may produce them, or because the microorganism produce them, but is not clear, the toxicity of those metabolites is not clear. Then, as we see here, the step 3, for instance, is the determination of which of these metabolites of potential concern are actually of concern. So the guidance document, the decision tree of the guidance document, ends up in a list, basically, in a list which contains the metabolites which are considered of concern, and which are those which will be assessed for instance, human toxicology or ecotoxicology. The guidance document will enter into force by the end of this year, but is already available because it's been published last year in 2020. The second guidance document we published last year is the one concerning approval and low-risk criteria linked to antimicrobial resistance. As we know, antimicrobial resistance is a serious problem. According to OECD statistics, every year in Europe, more than 30,000 people die because of antimicrobial resistance of pathogenic microorganisms. The problem with antimicrobial resistance is that it's horizontally transferable. So what we want to approve is not a pathogenic microorganism for sure, but if the microorganism is not pathogenic, but can transfer the gene for the resistance to antimicrobials to other microorganisms, this could be a problem, because this gene can reach pathogenic bacteria which are present into the environment and which can be difficult to be treated if infecting human beings. So the guidance basically, on one end, is keeping the safety level high. On the other, doesn't want to give a useless burden to the companies, as we said before. So what we are asking for is information on possible genes, which are, first of all, transferable. Secondly, and which concerns those antimicrobials which are considered medically important by WHO, so which are actually used in the human and veterinary medicine. The guidance has 2 steps. One is WGS, so whole genome sequencing, and then the second one is a phenotypic step. The guidance is already available, public available, because published last year, and will enter into force in 2021. And that's it from my side. Open for questions. Thank you.
Thank you, Domenico. I saw that there are 2 questions for you in the chat. The first one is from Jeremy Sweet, and the question is Sante considering data requirements RNA-based pesticides, or when will they do this?
We have not a position on that yet. High RNA is surely something which is under the attention at the moment because it's promising, but we have not consulted member state yet on that. So our activities at the moment, at least in our unit, are focusing, as regard pesticide, are focusing on other biological alternatives. But well, the future is yet to come. We are open for developments and see how does it go.
Thank you. And the other one is by Swan Chang. And the question is the EU approval product could be applied directly in different member countries, or it still needs further authorization from the specific country in order to apply the product?
The second. So what we approve at European level is the active substance. The active substance is approved based on the vote of member states, because the Standing Committee of Plant, Animal, Food and Feed is composed by delegations of the member state, but still the active substance is the only one approved at this level. Then the product needs to be approved at member state level, authorized, at member state level. There are systems of mutual recognitions which make the things smoother, but still product has to be authorized at member state level.
Thank you.
Approved, sorry.
I'm sorry, can I have, thank you for your answering. Can I have a follow-up question? Because I'm typing a bit slow. So in this case, it means like, for example, certain kind of product might be only be available like in certain kind of country in EU, but not all of the countries. Depends on who already authorized the product, right? If I understand correctly.
Yeah, it can be the case. Yeah, it depends. Some company may just be interested in asking for authorization in certain countries rather than others. Can be the case. Yeah.
So it means that if it's only approved in Germany, I cannot use it in, I mean, other countries, right? In EU, I cannot just buy the product in, for example, in Germany, and then bring it to other place and use it, right? That's what you mean.
The plant protection product, yes, because it is dealt at member state level, while the active substance is European level.
Okay. Okay. Thank you so much for your answer.
Thank you.
So thank you again, Domenico. And let's move to the last presenter. That is Paolo Lenzi from Efsa. Hello, Paolo. Good afternoon.
Hello, good afternoon. Can you hear me?
Yes, we can. So the title of his presentation is The Risk Assessment of RNAi GM Crops. Thank you again, and the floor is yours.
Okay, thank you. Can you see my screen? Let me put it like this. Yeah. Okay, so thank you. Thanks to the organizers for inviting me. My name is Paolo Lenzi. I'm a scientific officer at Efsa. And today I'm going to talk about Efsa's activities on the risk assessment of RNAi-based genetically modified crops. So here, just to give you a very general introduction, Efsa is responsible to perform a pre-market risk assessment of genetically modified organisms with regards to human and animal health and with regard to the environment. The risk assessment is performed by the GMO panel, ad hoc experts, and members, the scientific officers of the GMO unit at Efsa. We've assessed GM crops, as you can imagine, the most common ones: soybean, maize, oilseed rape, cotton, and we've dealt with major traits, mainly insect-resistant genes, herbicide tolerance, either as single events or stacked events. More in particular, as regards the RNAi technology, it is, of course, used as a tool to downregulate specific endogenous implanted genes, but also to downregulate genes in insect pests. So with this double-stranded RNA or molecules that can elicit the silencing response. So just to clarify, in this presentation, I'm going to talk about the expression of cassettes that are integrated in the plant genome and are responsible for the expression of the sequences that produce the double-stranded RNA in plants. So in this presentation, I'm going to go over these 4 points, which are the kind of chronological review of all the activities Efsa has been involved in over time as regards to the application of RNAi in GM crops. And so the discussion started in 2014 when Efsa held an international workshop on RNAi, in which members of academia, research, industry, regulators gathered to discuss about the application of this technology in GM crops. Later on, Efsa launched 3 procurements aimed at producing a systematic literature review of all the scientific publications available on the topic, focusing on the 3 main areas of the risk assessment: the MC, molecular characterization, environmental risk assessment, and food and feed. And then in 2017, the GMO panel published an internal note with a strategy for the assessment of RNAi off-target analysis. And then at the end, we mentioned this as a case study, the risk assessment of a GM maize resistant to Western corn rootworm in 2018. And this is mentioned as a case study, as I said, because it was the first application that was assessed, taking into consideration all the requirements that were discussed in the above mentioned activities. So the workshop 2014, in this workshop, there was a discussion about important topics related to the risk assessment of RNAi technology applied to crops. And the discussion was focused on these three main areas of the risk assessment. So molecular characterization, food and feed uses, and the environmental risk assessment. So the workshop reviewed the scientific knowledge available, explored the RNAi-based applications, identified common issues in the application of these technologies, and also explored whether the current risk assessment framework had to be refined. So without going into too many details, I just would like to give you an overview of the key messages within these three main areas. So starting with molecular characterization of the risk assessment, the discussion considered the importance of off-targets and off-target effects in the RNAi technology when it's applied to plants. Of course, as we know, this technology relies on the complementarity of the the small interfering RNA to a transcript. And so this complementarity or partial complementarity could complementarity to non-intended transcript could trigger an unintended silencing effect on other transcripts, not only towards endogenous plant genes, but also towards genes contained in any other organism that comes into contact with these plants. For the discussion was also important is the processing of these ingested molecules, because we know that some organisms are able to process internally the double-stranded RNA molecules. Of course, the molecule intake, the processing, the mode of action may differ between the different taxonomic groups, and these concepts were also considered in this publication, which is the final report that came up out of that procurement that I mentioned before. Moving on, if we consider the main aspects coming out of that discussion regarding the food and feed, deals with possible hazards for human and animals upon ingestion of this plant material. So based on those feeding studies, there was a low absorption of these molecules. So the uptake of this, generally speaking, non-coding RNA molecules was taken into consideration, and the amount of this dietary silencing RNA absorbed upon digestion could be considered negligible for humans and animals. Even if we consider the respiratory route, for example, both pollen and any agricultural dust are made of large particles that don't tend to migrate too much into the capillaries in the lung. So basically, there's no evidence of absorption of these molecules from the air by inhalation. Also, it was important to consider how useful tox studies for animals could be when it comes to the application of this technology. And for that, we also have to, again, take into consideration the properties of these molecules. The absorption level of this double-stranded RNA upon ingestion, the stability of these molecules, which is very low, the degradation rate, which is very high, and so also the fact that these molecules have to pass physical barriers upon ingestion, barriers made of cellular and intercellular layers. So basically there's no evidence for toxicity of these molecules after ingestion. taken all these factors into consideration, it was decided basically that animal studies for these RNAi molecules were not relevant when it comes to the risk assessment for food and feed, just because the amount present in the organ in humans, on animals in general upon ingestion is is negligible. Regarding the environmental risk assessment, it is important to consider the off-targets for non-targeting organisms. So we know, as I said, that sufficient homology of this small interfering RNA to other transcript, which is not the intended transcript, could trigger off-target effects. A substantial overlap of 21 base pairs is sufficient to trigger the off-target effect, but also mismatches can be allowed. So let's say that bioinformatic tools could be a handy tool to study and predict these off-target effects, but they cannot replace 100% the toxicity studies when it comes to environmental risk assessment at the moment. And this is because these in silico predictions are subject to limitations. We don't have the sequencing information for all the possible non-targeting organisms. There are differences between different non-targeting organisms when it comes to how they process these molecules. And so we definitely need more substantial genome data to use these bioinformatic tools. So if a test has to be considered for ecotoxicological studies, these double-stranded molecules could be used as test materials. And so for this non-targeting organism, implant material can be used in lab bioassays, basically. And for this, a tiered approach remains appropriate. So when basically the highest exposure levels are considered, which are usually unrealistic or unlikely to occur, and if there are no potential hazards are identified, then no further testing are basically necessary. Okay, so I mentioned the procurement in 2017. Efsa launched these 3 procurements to have a systematic literature review. And these are the 3 final reports that came out of that literature review, focusing on the 3 main areas of the risk assessment. So molecular characterization, food and feed, and environmental risk assessment. Another important activity regarding this topic was the publication in 2017 by the GMO panel of an internal note on the strategy and the technical aspects of this small RNA off-target when it comes to bioinformatic studies. So this is the Annex 2 of the documents that presents the minutes of the 118th GMO panel meeting. And in these documents, there are considerations on the search algorithms, parameters, the number of different RNA showing similarity to potential of the target transcripts, or the established or predicted function of this potential of target transcripts. So the degree, and we know that the degree and the position of the base pairing between these molecules is important in determining the efficiency of the silencing. And so all these in silico target prediction are designed taking into consideration the binding energy and the base pairing. But there are other factors that are considered that are important, like, for example, the abundance of this RNA molecule produced. So this technical note is today important when it comes to risk assessment for the molecular characterization of these products. And then the fourth point, as I mentioned, is this the assessment of this genetically modified maize, the MON 87411 event for food and feed uses, import and processing. That was assessed under the regulation number 1829 of the 2003. And it's this application presented a GM maize resistant to the Western corn rootworm. So this maize presented an expression cassette expressing a CRY gene, BT gene. A gene confers tolerance to herbicides, but more importantly, an expression cassette for the expression of a 240 nucleotide long double-stranded RNA molecule that was used to downregulate the SNF7 transcript in the larvae of the worm, in this worm. And the downregulation of this gene caused pest mortality. So regarding the assessment of this application, the applicant provided the off-target analysis of endogenous plant genes, and this off-target search did not provide indication of any off-target effect that could raise safety issues. The applicant also provided a measurement of double-stranded RNA levels, which was not considered for this assessment. And this is because the experts realized that the plant itself has the machinery to somehow process some of these double-stranded RNAs. So the double-stranded RNA is not a good proxy for the levels of small interfering RNA. So basically, the expression levels of the double-stranded RNA is not necessary for the assessment of this double-strand of these plant products. Regarding the food and feed aspects of the assessment, the applicant provided a 28-day tox study, again, which was not considered, was not assessed, because, again, because of all the things that we've said in previously, the amount of these molecules is pretty much negligible in humans and animals. And so the 28-day study, which is typical for proteins, for example, and its requirement for newly expressed proteins is not necessary for double-stranded RNA molecules. And then when it comes to the environmental risk assessment, no or very limited exposure of GM maize was expected. So if I have to jump to conclusions, I can say that there are no dedicated guidelines for the risk assessment of RNAi technology when it's applied to GM crops, but the current risk assessment approaches could be considered suitable today to perform a risk assessment with some additional considerations. And these additional considerations are regarding the molecular characterization, an analysis of the off-target effects adds value to the risk assessment, and it's actually required. Analysis of the off-target effects of the endogenous genes, of plant genes. The expression levels of the double-stranded RNA molecules is not relevant for the food and feed safety assessment. Regarding the food and feed part of the assessment, animal studies to assess the toxicity of these double-stranded RNAs are not justified based on the current knowledge. So basically, they're not required. And when it comes to the environmental risk assessment, well, we have to consider that these applications exclude the cultivation in Europe. So all the things that I've said previously lose importance at this stage here, because pretty much these plants are not cultivated in Europe. If non-targeting arthropods insects feed directly on these double-stranded RNA expressing plants, or if consumption of plant-fed animals is expected, then further information for exposure assessment will be needed. And then in that case, bioinformatic tools can be used in conjunction with agrophenol compo data. So this was all I had to say regarding the status of the risk assessment for RNAi-based GM crops. I'd like to thank the GMO panel, experts, and colleagues at the GMO unit in Efsa. And thank you for your attention.
Thank you. Any specific question for him?
Well, if I can say that I'm really glad to know that you are presenting now the fact that there was this agreement not to consider scientifically justify the request of toxicity study and also double-strand level of expression, double-strand RNA level of expression. I think that is in some way a positive and interesting result, because for who is going to set up for the risk assessment, at least from this information, we know that these two things that sometimes are expensive or takes time consuming can be probably avoided. Is that something that you keep it also for future potential new plant product, including a plant product not only for import, but so food and feed, but also for the air analysis?
Yes, basically, when it comes to double-stranded RNA molecules, yeah. So basically, there is evidence that the expression levels of the double-stranded molecules is not an indication of the potential amount of small interfering RNA. So at that point, the expression levels don't have the same importance that protein expression level might have in a normal application where newly expressed proteins have to be assessed.
And the same for the toxicity study, if I understand it.
And the same for the toxicity study when it comes to food and feed, so for human and mammals in general, just because there is evidence that the amount of RNA molecules that are present upon ingestion is negligible, and there are several barriers that have to face, and so the silencing effect of these molecules is pretty much negligible for humans. So
this is very good news, I would say. It helps. Yep. We know that we have to do a lot of things, but if we can take off this, it's already good news.
Any other questions?
Well, we can maybe take a break, not to take a break, just show again the video and then go to our table, and maybe other questions will come out. Thank you, Paolo Lenzi, for this very interesting introduction. Well, people that were connected this morning, I've already seen this video. I will show again for people connecting today in the afternoon. And sorry, it's here. And again, this video was prepared following in some ways the message that we identified for the publication that I showed you before on trends in biotechnology. And we think that it's a good message summarizing most of the activity and discussion we had during this meeting, during the activity of the project. I start again the video, so our 5 minutes.
Hey! Oh yes, I'm talking to you. Just some quick questions. Ready? Could you imagine a world without tomatoes? Could you imagine a world without barley? Could you really imagine a world without bees? I guess your answer is no. Just like the European Commission, which has established the Farm to Fork strategy, a pillar in the Green New Deal. Among its aims, there is a progressive reduction in biodiversity loss through a 50% dismissal in agrochemical inputs, such as pesticides. The ultimate aim is to reach a more sustainable and food-secure society by 2030. Hi, Mark. This is Mark, a grower who takes to heart global sustainability policies for agriculture and food. He wants to ensure sustainable food production without using contentious pesticides. But still, plants need protection. Growers need tools to protect them. And the whole world needs food, as well as security and safety. We need a safe, efficient, and cost-effective alternative. Mark can choose between two options: stop using contentious pesticides and give in to pest infections and production loss, or stop using contentious pesticides while giving a chance to new technologies. Don't worry, Mark. Among new technologies, there's one called RNAi-based biocontrol that uses a well-known biological process in most living organisms and protects plants with a safer and more sustainable approach than contentious chemical pesticides. Did you know this? RNAi molecules can regulate gene expression by targeting specific endogenous mRNA molecules and can be designed to target genes that control the infection and disease development of pest and disease. RNAi molecules impact neither the environment because of their high and fast degradability, nor other organisms, including consumers, because of the well-controlled risk of off-target effects. Imagine you're in front of your vineyard on a rainy day. This is what you did until now: damage the plants, making use of the heavy knapsack sprayer more than once because most fungal diseases are favored by moist conditions. This is what you can do from now on. Exploit this new technology through exogenous applications of formulated RNAi-based products, such as a spray applied only once. Or even better, to benefit from the in-plant delivery RNAi through GM crops. One technology, two opportunities: either pest and disease protected plants or pest and disease resistant plants. And there's more. Mark isn't the only one who benefits from this, but the consumer does as well. This technology isn't dangerous for human health or the environment. The European Commission preserves biosafety thanks to the control of EFSA's specialized panel on RNAi-based plants, and plants protected by the exogenous application approach aren't considered GMO. Besides that, the two approaches offer ease of design and test, high efficacy and specificity for different pests and diseases, fast degradability, good predictability and control for potential risks. The RNAi-based technology produces new attractive products for seeds and nurseries industries interested in spreading and trading resistant and higher quality plants and products. The agribusiness sector is already investing in this technology and looking forward to developing RNAi-based resistant plants and RNAi-based products that protect plants, in both cases with high biosafety profiles for consumers and the environment. So, as you can see, aims from Farm to Fork strategy are achievable. Solutions to the problem of the reduction in contentious pesticide usage already exist, and they're at your fingertips. Tomatoes, barley, bees can keep on living, and us as well, but in a more sustainable and food-secure world, embracing safe, efficient, and cost-effective alternatives, like the use of RNAi technology. All it takes for a real change is to get informed, and it'll be clear that think green means understand green and look at real green solutions.
Thank you, Bruno. So the video will be available on the iPlanra website, So feel free to use it and to spread it and to use it as a dissemination tool. Okay, so let's move to the next, to the final roundtable. And for this, I leave the floor to Jeremy Sweet, who is the co-chair of the iPlanra section, and will be the chair of the final roundtable. So, Jeremy.
Thank you, Vera. Good afternoon, everybody.
Good afternoon.
If it is afternoon with you, it may be morning or evening for some of you. But anyway, thank you and welcome to this webinar, which has been very interesting. Following on from the one this morning, which I also found interesting to get the growers and the industry perspectives on a lot of these new technologies. We'll have a discussion now about some of the issues that we've heard about this afternoon, but also perhaps this morning as well, for those of you who are with us. But I'd first of all like to ask Nevena if she would like to make any particular statement. I know we heard from your colleague in FAO, but I wondered if you had anything to add to the comments that he made about the role of FAO. So it's an opportunity for you to speak. We've heard from all the other speakers, but I just wondered if you wanted to make some comments at this stage.
Thank you, Jeremy, and good afternoon to everybody. Unfortunately, at some point in the afternoon, I had problems with the connectivity since I'm working from home since a year or more, as many of you. And I could not hear my colleague's statement, nor I missed some parts of the statements of the other presenters. If you don't mind, I would like to just say a couple of words that refer to regulations and policies in general. And they are, actually, I wanted to share with you a few highlights of a very recent report from the UN, United Nations Conference for Trade and Development, that is called Technology and Innovation Report for 2021. And it is focused on innovation and equity. So basically the report says that emerging technologies can foster an inclusive COVID-19 recovery. And we know that we expect serious consequences on the food systems, but also much beyond on the economies from the COVID-19, such as 550 million people are expected to be pushed back to behind the poverty line. Serious drop of the GDPs in different countries, like 5%, which we haven't experienced in the past 20 or more years. Also during the current economic crisis, or maybe in 10 years or more than 10 years. So this serious impacts can be helped and overcome with technologies. And this report is specifically focusing on frontier technologies, 11 types of technologies, and one of them is gene editing, and largely they also include RNAi technologies there. So they also see that the technological change widens the inequality in the countries between poor and rich people, but also and most over inequality in the world between developing and developed countries. And this is actually a serious barrier to achieve the sustainable development goals, but basically on the development, agricultural development, and overall development in the world. The way we cope with our problems. So they also said that these technologies, all the 11 types, represent a big market now. So overall, today, actually, 3 years ago, they were $550 billion, and in 4 years' time, they're expected to grow to $3.2 trillion market. And this is a serious growth, technological growth, but the society needs to adapt, needs to develop the ability to cope with this technological change that actually has the potential to deepen the inequality. So when we talk about policies, when we talk about regulations, we have to change our perspective for regulations. So they are not only having the objective to protect human health and environment, which will stay, that's very valid, but they need to prepare the society to adapt, which means that flexibility has to be ensured in those regulations so that they can do the regulatory work to readjust the knowledge and the measures in order to and I would like to state exactly the words from the report. We can harness the potential of those technologies for common good, and we have an obligation to do so. So it is, we are in the phase in our development that we have really serious obligations to resolve the problems related to technologies that are going to happen with science-based and evidence-based policies, with the efforts of scientists and the society and education. And as a molecular biologist, I am happy that finally the society learned what PCR tests are, and they know now, more of them, what is the mechanism of the vaccines, especially the new vaccines for COVID, but we had paid a very serious price for this knowledge, to fasten the speed of the knowledge that society acquired. I don't want this to happen in future. So it's really our role as scientists and policymakers and teachers in the schools and universities to prepare the society to the level that we will be able to deal with the problems before the damage is happening. Thank you very much.
Thank you very much, Nevena. I think you make a very interesting and useful point. One of the things that we also learned from the COVID virus infection is that when there is flexibility in regulation, we can advance new vaccines incredibly rapidly and get them into production and get them being injected into people. These vaccines include genetically modified viruses and messenger RNA. And yet there has not been, or has been very few people criticizing this progress and this rapid deregulation of these products. And I think it's just an example of what we can do when we really want to. I think it's also frustrating that certain senior political leaders in 2 major European countries cast doubt on a vaccine just because there wasn't sufficient data. And that has meant that a number of people are now rejecting one of the vaccines because they don't think it works. And so I think it's very important that when senior political and influential figures make comments, they do it purely from the basis of science, and they don't do it because of other reasons. And I think you know, the impact that this has had on people's attitude towards, for example, the AstraZeneca vaccine has been very bad, when there's no doubt that it is efficacious, and yet they said it wasn't. And what the situation was really that we had a lack of data to complete the deregulation. So yes, it does show that if we want to, we can be flexible and we can approve products. We can approve products which we are actually injecting into our arms, which we refuse to accept on our food tables. And I find this most extraordinary, and I find it very frustrating. I think also it's interesting, for example, going back to Gisella's talk, that she was talking about the amount of investment that has been by the European Union in research on new technologies. And Bruno and I have experience of this in relation to GMOs, and also Salvatore, who I see is with us today. There have been a huge amount of research, both on the technology and on its biosafety. And yet the results of that research are not accepted by a large proportion of member states in Europe. And this again is not acceptable. This means that the good science that has been done, that has been paid for by the taxpayers of Europe, is not being accepted at the European level. And I find this most extraordinary, and it is about time that we made people realize that these things have huge value, that they can make a major contribution. And I think if we want the Green Deal and the farm to fork products to go ahead, we need to, as you say, Nevena, we need to seriously look at how we're dealing with regulation, and to facilitate the introduction of innovation instead of blocking it, as a number of European and other countries are doing at the moment. So I'll get off my soapbox for a minute and invite other people to comment on that. So would anyone else like to comment?
Well, thank you, Jeremy. Thank you, Nevena. I want also to remember that there are two questions on the chart that maybe we can, one is from the beginning, that is from Marco Pasti, that is RNAi GM plants could be considered more environmentally friendly than applied double-strand RNA, since they don't require additional energy and other resources for production, packaging, transportation, and application. So this is quite a strong statement. I don't know if somebody wants to comment it. Is clearly in favor of GMOs and on product. I think we should.
Does anyone want to comment on that? Otherwise, I will comment. I think the most, excuse me, the most efficient way to control pests and diseases is through plant genetic resources. This has been shown with conventional breeding and other plant breeding techniques. So if we can breed plants to express double-stranded RNA to protect them against pests and diseases, this is a very efficient way of doing it, as long as it does remain durable. One of the problems is that when you genetically, when you put resistance into a plant, it means that the pathogen can be exposed to that resistance for a long time. It can modify, it can adapt, and there may be a problem of the longevity of that resistance. So it may mean that after a little while you have to breed in more genes, and so you have what we in plant breeding have called the boom-bust cycle. So you get the boom, which is the good resistance, and it works for a while, and then there's a bust because a new strain comes along which overrules it. So it does mean that you don't just produce one plant and say, this is it, I've cracked it. You have to have a plant breeding program that goes on. And therefore, obviously, when you're looking at the resources and doing the sustainability assessment, you have to take that into account. But generally, yes, it is an efficient system if it is sustainable and if it lasts for a long time. Anyone else wish to comment?
I think no, I don't know. Salvatore is asking probably to Paolo Lenzi if regarding double-strand RNA expression analysis, what he reported was for the food and feed. He's asking if eventually when there is an application for cultivation, maybe it's interesting or requested to have the double-strand RNA expression analysis.
Yes, Bruno, the issue is that in the case of non-target organisms, we do need this expression analysis in order to focus our exposure assessment. Because, well, we know that probably it's the double-strand RNA is cleaved in a pool of single interfering RNA, but it's unlikely that it could be more toxic than the double-strand RNA itself, the number. So the idea is that in order to select the best non-target species which could be exposed, we need to know which plant parts are in fact expressing this double-strand RNA. For instance, this could allow, I mean, just an example, to exclude pollinators or root feeders if we do know that there is no double-strand RNA expression in some specific tissues.
Okay, thanks very much, Salvatore. Any other questions, comments? Maybe we could just change direction and move away from regulation for a moment and discuss the farm and fork issue, farm to fork issue. We've heard people commenting on it and making various statements this morning and this afternoon. One of the concerns that I have, and maybe some other people have, is that we wish to move towards more organic agriculture, which we know means that productivity per acre or per area of land declines. We also want to go for what is called rewilding in this country, which is to convert agricultural land back to nature. So, and there's a target there, I think, of 10%. So this means that effectively we are going to reduce the productivity of our agricultural land in Europe. This is at a time when we need to produce more. And there's a danger that if we do this, what it means is that we will be even more dependent on imports into Europe than we are at the moment. And we are already using a lot of the agricultural land and resources of third countries to supply Europe, particularly for animal feedstuffs. So I'm just wondering if people would like to comment on these aspects of the policy of farm to fork, because I think it creates a dilemma, and maybe the only solution is, as suggested, I think, by FAO, which we have more sustainable intensification. But that requires that we do adopt, it makes it even more of a priority that we adopt these new technologies. Because if we want more intensification, one of the main tools is through these different, both plant breeding and crop protection strategies. So does anyone want to comment on that?
If I may, just because you've mentioned FAO, if I may clarify a little bit regarding the current thinking in the organization as to how the world might achieve this challenge of producing more with less. Though the new strategy, well, let me take a step back. We have a new leadership in the organization, a new director general, that is emphatic that he wants to lead the organization to impact positively on 200 million people in the course of his tenure. And he wants to do this leveraging green development. So what this implies is that FAO is advocating a knowledge-intensive agricultural and food system whereby all validated tools, technologies are on the table. And coming nearer home to my own area of work, plant production and protection, we are also now articulating how we can contribute to these 4 aspirations of the organization, better production being essentially produce more with less environmental footprint left by agriculture, better nutrition. The SOFI report of 2020 pointed out that it's increasingly difficult to access the nutritious food that we need to address the scourge of malnutrition in the world. So to that extent, for us, in plant production, this would entail, as you have seen, as you have said, Jeremy, breeding nutrient-dense crops and varieties, and also the diversification, inter- and intra-specific diversity of the food that we eat. The better environment is obvious. Agriculture should have as little footprint as possible, and the overarching thing is better life. So people are able to, in general, lead good lives. How do we intend to address this in specific terms in the Plant Production and Protection Division? We are looking at essentially three main technologies. Seed technologies, which is essentially unlocking the potentials that are encoded into the genetic blueprint of our crops. And again, genome editing, RNA interference, whatever tools that are validated should be on the table, so long as the internationally agreed frameworks for assuring safety are followed. And I would say the world is beginning to lag behind now in terms of coming together to build consensus around genome editing. The same kind of, you have on one end the United States and Australia saying there is no need for regulation. At the other extreme, you have the EU and say New Zealand requiring some further regulation. But in the middle are all these food insecure countries that lack the capacity for the evidence-based decision making, meaning that there is a need for a global forum to agree on how to manage this very powerful technology, how to address the concerns, of course, that arise, the ethics, the gene drive, and things like that. So that is that about the seed technologies, unlocking the potentials that are encoded into the genetic blueprint, and then also the cropping technologies, smart agronomics, underpinned by the best science, precision agriculture, precision fertilization, and protection. And as our director likes to frame it, we are talking about optimization of returns on investment and the inputs that are used, minimization again of losses and footprints, and then maximization of benefits for all. So this is the way that, this is our current thinking. It doesn't have to be one or the other. We are going to feed the world, but it's going to be a knowledge-intensive revolution, because the world is not just going to say, oh, we get everybody fed, but we destroy the future, the environment for the future generation. Thank you very much. Over.
Thank you very much, GK. Just to follow up on that, though, isn't this the role of the COP and CBD to harmonize, try an attempt anyway, to get harmonization of regulations around the world? So it's your brother or sister organization that has this function.
Well, I mean, the CBD, the Convention of Biological Diversity, provided the mechanism for the Cartagena Protocol on Biosafety, for instance. And currently, the CBD is addressing genome editing, gene drive, digital sequence information. Is addressing all these within this omnibus theme of synthetic biology, which in itself is also a discipline of biotechnology. So whether it is under the auspices of the CBD or it's under the auspices of FAO or through some other intergovernmental process, I think that a technology that is as powerful as genome editing, that is demonstrably cheap, relatively cheap and easy to use, requires consideration, requires some consideration in a way that, you know, the consuming public has confidence in the products and has faith in the science. Of course, I heard what you said earlier. Why would people accept to be injected, to have injected into their arms what they would not have on their dinner table? But that is a story for another day. The thing that we are concerned about is how do we be the generation that finally abolishes hunger and malnutrition. And science has a role to play, as it has always played. This is the vision of the current leadership of FAO. Thank you. Over.
Thank you. Just to follow up on that, there's a question from Cecilia Gonzalez from Bolivia. Yes. Good morning to Bolivia. I'm very glad you're with us, Cecilia. And again, this relates to the regulations, I guess, in Bolivia and what is happening there. I guess the quick answer would be that you have a look at what is going on in your neighboring countries of Argentina and Brazil, who are deregulating GM crops and are approving them and cultivating them. So maybe Bolivia should be looking at lessons there. But maybe also there's an educational program, and maybe Nevena, you could answer me. Do we know if Bolivia has been involved in any of the FAO or UN programs on educating them on regulation and bringing them into line with Cartagena?
Thank you, Jeremy. FAO has been involved in the past in a vast program that would include something around 100 countries around the world. I'm not sure about Bolivia, whether it has been part of these programs. They were different with different focuses, but also, as you know, UNEP and the World Bank have done such biosafety programs on GMO regulations, including. I guess those exist, but if I may just comment on what can be done to bring policymakers more around the science-based policies, what is actually, you know, we know that NGOs, environmental NGOs have been very effective and efficient because they do advocacy, and scientists usually don't do advocacy, but they rather discuss among themselves and try to seek agreement among themselves. So maybe it's high time that scientists go behave more as an activists and do advocacy rather than do their current job to develop different science products, or somehow they have to find a balance. And of course, education should play a greater role, but the education is not currently under the FAO mandate purely. So this is really a joint work with the United Nations that requires a lot of transformation, societal transformation, in order that we achieve the right level of knowledge and science-based approaches. Thank you.
Thanks, Navinda. Does anyone want to comment on that? Including our expert advocate, Bruno. Do you want to comment on advocacy?
No, I want just to comment this aspect by asking Chike about what he mentioned in his presentation on the FAO plan of managing field trials. And so how far in these field trials networks that you are managing or creating, I understand that you have this as a priority in your program, that I suppose is mostly related to testing seeds, or plants, and so on. How far potentially new seeds, new products like this derived from biotechnology could be included in your demonstration activity, field trial demonstration activity? In my opinion, this is really a potential, a powerful strategy, not to convince people, but itself, but to show what can be the potential benefit of a technology. When you show a new product, a new plant, and so on. Because again, just as teaching and say that is not a GMO, maybe it's GMO, that is a new technology, what is it? That clearly is important to in any case, to train and so on. But in some way, for me, it's really important also to show the plant. What can be the benefit of the plant? What can be the benefit of the plant? Of the maybe new product in this case. But so what is the possibility to include in your network some kind of new product derived from this kind of biotechnology?
Okay, thank you very much, Bruno. We don't have anything akin to like a multi-country, multi-locational trial system. No, we don't do that. Sometimes there are regional projects that cut across multiple crops. But we don't have a standing program for a network of field trials. So having said that, FAO usually responds to requests. There, requests from its members. It could be a request from a member for technical assistance, or it could also be a request from the governing body system to carry out certain work. So we are a member-driven organization. We do basically what the members ask us to do. So the kind of field operations that we have, the demo plots, would usually be in response to a particular request by a member that could be funded by, our regular technical cooperation programs, or extra budgetary funds, say from the EU. EU is like the second largest funder of FAO activities. But regarding biotechnologies per se, FAO's approach to this is a recognition, a firm recognition that biotechnologies, including genetically modified organisms, can contribute to addressing the problem of food insecurity and malnutrition. However, FAO is also aware of the concerns, that is expressed in different quarters, and therefore we advocate for a case-by-case evaluation of each particular technology in a context-specific manner. Should a member require assistance, FAO is obliged to help that member access information, build institutional and human capacities in order to be able to make evidence-based decisions. At no point does FAO ever come and tell a member country, a member nation, oh, you must use GM crops, or you cannot use GM crops. So we pride ourselves, or the organization prides itself in the ability to work with any particular member to build its own institutional and human capacities in order to be able to make that evidence-based decision. And if I may speak to the question from Bolivia, yes, in the past, there was a plethora of funding opportunities from UNEP, from the World Bank, and to some extent even FAO, to support the biosafety capacity. But that is not to say that funding cannot be obtained now. I'm supporting a project currently in Sri Lanka. It is funded by the Global Environment Facility, GEF, for strengthening the national biosafety framework. So this probably is a kind of mechanism that Bolivia can, explore, so that it builds its own capacities internally. Bolivia is somewhat different politically and otherwise from Argentina and Brazil, so that it decides how it can manage the adoption or not of particular biotechnologies in addressing its quest for sustainable food security and nutrition. Thank you. Over.
Thank you, Chico, for that. Do you want to come back on that, Bruno, or are you?
No, well,
I was
aware more or less of how it works for FAO, but yeah, I think that this idea to have to see if there is a possibility to be involved, or to not to promote, but to increase the capacity of the different countries in testing new technology. I think that is a really important thing for the future and for the development of the technology, and also maybe, hopefully, for the development of the agricultural system in that countries.
I think it's also interesting that there are various programs, the Cornell University and the Gates Foundation and so on in a number of developing countries where they are encouraging people to trial and test and look at new GM products like bananas and some of the crops which are perhaps not of interest to the big biotech companies, but are of high value in some developing countries. So there are other routes, I guess, towards testing and trialing technologies. And it is interesting that I think the last report that came out from ISAAA suggested that the uptake of GM crops was now faster in developing countries than in developed countries. So I think it shows that if you show farmers and the countries the benefits of GM crops, then they're more likely to adopt them, particularly for local requirements. I think the concern has been about the export markets from these countries, but if the crops are for consumption or feeding animals in their own countries, then they are very interested. So I see the comment from Nevena, which is very useful. I hadn't realized that that you'd only just appointed the first chief scientist for FAO. I thought you had a lot of scientists or senior scientists in FAO, including yourself and Chike.
Jeremy, if Domenico is still connected, may I have a question to him? Domenico, are you still there?
Salvatore has his hand up.
Oh yeah, I don't know if that is related to an old question or a new question.
Well, in fact, I have replied also in the chat with Cecilia, so we exchange a little comments on her question. Thanks.
Yes, I saw that. Thanks very much, Salvatore. Yeah. Is Domenico there? Have you unmuted now, Domenico?
Well, I have two questions. One, let's say, related to the terminology, because in your presentation, you use the terms metabolite. So the mandate of your process, of your office, in some way, your DG Sante, and I suppose also in Efsa, is to test new metabolites. And this morning we had a little bit of discussion about chemicals, no? So general chemicals. So everything is chemicals. But we see that there is a difference between chemicals and chemicals. So in your case, in your view, any kind of chemicals is a metabolite. So what is the question? Is double-stranded RNA considered as a standard metabolite or not? Because in your opinion, I don't know, I know that you are not really working on this, but I don't know if you have some feeling about it, because in reality we are speaking about nucleotides, and in specific in this case of short sequence nucleotides. So I don't know if you have a view of that. And then after, I have, let's say, a kind of other general question. You show the way to present a dossier, no? Well, here there is always a big debate on the fact that now it's very difficult to submit dossier for having the approval of new compounds, of new metabolites, new type of products. And so, and there is, I think that is another important discussion. It looks like that everything can be managed only by big industry, so by the big industry. While maybe particularly also in this area, there are now new studies coming also from small groups and so on. So how far it can be possible, how far it can be accessible, the approval of a new, of the preparation of a dossier for the approval of a new product, even, let's say, not in a high cost, and so in a way accessible also not to big industry, but maybe also spin-off for small groups that decide to develop a new product and things that can be transferred to the market.
Yes, so thank you for your question on metabolite. Indeed, that's a good specification, because first of all, it's important to make a distinction between what is considered a metabolite in the chemical world, let's say, and what is considered a metabolite in the microbiological one. Because like in the part A of our regulations of the data requirements, when we talk about data requirements for chemical active substances, metabolites are mentioned, but those refers mostly to, for instance, breakdown products of the primary active substances. While when we talk about microorganisms, we talk about metabolites in its biological sense. So what is produced by the microorganisms, but for our purposes, what we are interested for are the metabolites of the secondary metabolites. So iRNA might be considered, but if they, for being a secondary metabolite, it should not be part of the primary metabolism. So I guess it really depends on the scope of the high RNA we are talking about. But this is something which needs to be taken into consideration case by case if the high RNA falls under this definition. So say you're talking about a microorganism which produces like high RNA, which is not the housekeeping, let's say, housekeeping high RNA, that might be considered, I guess, a secondary metabolite. On as your second question, I'm not in the position to reply as regards cost for companies, but of course this really depends on the kind of microorganism the company would take to the market. Because if you as a company would try to approve something for which there is a lot of knowledge around, like there's say a lot of published study available in the literature, like literature review doesn't cost much compared to animal studies, of course. So this might really be in favor of reducing costs also for the applicants. But it's really depending on case by case, I guess. The effort we are putting in this amendment of the regulation is also on that. As I said during my presentation, we are trying the best to reduce as much as possible animal studies for many reasons, among those like ethical reasons, but also to reduce unnecessary burden for companies. Just because of the example you mentioned, like we want also to SMEs to get to the market, small and medium enterprises to get to the market and provide more tools for farmers quicker and in a cheaper way for them. It is important, however, to underline that to make the process smooth, reliable, and quick, also the companies need to provide the data which are required. Otherwise, like providing risk assessment and risk management without data is really a nightmare, believe me. With this data requirement, we're trying our best from our side, but it has to be a mutual effort.
No, absolutely, yes. I don't say that we don't have to have free access, but yeah, because this is also an important message, because everybody is thinking, oh, well, well, we are a small university, we are developing few products, and it looks like that, okay, and then what we do, how to go on the market. So I'm a little bit aware of the process of risk assessment because I was involved on more in the biotech part. But I think that also the issue of the dossier related to the pesticide is something not, I see it quite complicated. We need really to have at least some positive message, say, okay, at least try, at least provide the information that are possible. And if there is a possibility to have some reduction in terms of demand of additional data, that can help really a lot. Thankful for this comment. Sorry, I take this as a positive.
Could I just follow up on that with Domenico? Under the implementing regulation for GMOs, there was a lot of pressure from member states to include toxicity studies for all GMO registrations. So even GMOs, which we know produce completely harmless genes and also have been tested and toxicity tested several times in events which have been toxicity tested in other crops. There is still a requirement for toxicity studies, which means killing and dissecting a lot of rats. So though I hear what you say about pesticides, I wish you luck, because in relation to GMOs, that has not happened. And in fact, the implementing regulation went back on the EFSA recommendations and recommendations from other scientists.
But Jeremy, however, the Lenzi says that for the double-stranded RNA, they decided that animal toxicity study is, as far as I understand, is not required because recognized as not scientifically justified.
Yes, but that is the EFSA.
It can help also this.
Yeah, but that is the EFSA opinion. That is not the opinion of the Commission, which had to implement the implementary regulations. So EFSA produces a lot of scientific opinions which tend to be ignored at the risk management level, and that is the problem. That we now have an implementing regulation which says there must be tox studies for all GMOs, regardless of whether they're justified or not. And I think that also applies to RNAi GMOs. So though EFSA gave that opinion, I think at the moment it's not actually operational.
Well, if I can come back, we are really talking about two different regulations. So I'm really not fully aware about what happens in the GMO world under the regulatory point of view, because we are talking about completely different regulations. Of course, in our data requirements, we have a mention on the fact that if the microorganism is a GMO, it has to comply with the relevant regulation. But as far as I'm aware of, as of today, we have no GMO microorganism approved as a pesticide, as far as I'm aware of. But maybe something is missing in my mind at the moment. But yeah, again, there's also another thing to be taken into consideration. As I said during my presentation, maybe because most of the pesticides available on the market are chemicals, our mindset is always toward, let's say, the chemical approach. For microorganisms, what we are stressing much more in the new draft of the new regulation is that we need to clearly separate the assessment of the toxicity of the chemical components of the plant protection product from the assessment of the possible infectivity and pathogenicity of the microorganism. So those are really two different aspects which need to be dealt in a separate way, if I may say.
Yeah, okay, thanks for that clarification, Domenico. And obviously we wish you luck with having a much more rational approach to the development of these new pesticides. It's just that the experience with GMOs has been much more difficult than that. Okay, are there any other comments? I'm not quite sure what time we're due to finish, Vera.
We should, because we spent already lots of time connected today, so unless really there are other comments or questions. Well, we are happy to stay here and to have such a good discussion, but we should not take too much.
So maybe if anybody else has any burning issues or comments that they would like to raise, now's the opportunity. Otherwise, I'll hand back to Vera, who's coordinating all of this so successfully.
Thank you, Jeremy. So I think we can stop here. Let me just thank you again, all the speakers and the participants. It has been a very interesting session. I hope you enjoyed it as well. I remind you that the video can be found, the video of these two sessions will be on the iPlanra website. And I wish you a nice evening.
Well, Vera, remember that if everybody agrees, we can also take a virtual picture.
Yes, for sure. Yes, if you can switch on your camera, we can take a picture.
Maybe more people can turn on the camera. Let's wait for more people. So maybe other people that can.
They are coming.
Yes. Maybe Nicholas, Giovanni, and Shiro, Juliana. Okay.
You click at the bottom of your screen where the camera is.
Well, let me take a first one, and then we see some more. Well, more or less is the same. Okay.
Okay.
Let's take this one. Okay. Thank you.
Okay, thank you.
Thank you so much.
Thank you, everybody. Bye-bye.
Bye-bye.
Bye-bye to everybody.
Bye-bye. Thank you.
Thank you. Bye.
Bye-bye to everybody.
Bye.